Now the general procedure to find horizontal asymptotes is exactly how it's outlined in the statement of this problem. You just find both of these limits, and if either of those equals a real number, then that is a horizontal asymptote. Y equal to that real number is a horizontal asymptote for your function. Now there could be different asymptotes if those limits are different, but they could be equal, and I think that's what will happen in this case. So let's see. So the limit x goes to plus infinity. The procedure to calculate that type of limit is always the same. When you have a rational function like this, you divide by the highest degree of x, the highest power of x that shows up at the bottom. And that's x to the fifth. So 4x divided by x to the fifth, that's 4 over x to the fourth, plus 3 over x to the fifth, over that 5 plus 4 over x to the fifth. Now, you're thinking in terms of x getting bigger and bigger and bigger over time, so that means this is going to get very, very close to 0, right? 0, and that's 0. So that's 0 over 5. So that's 0. So that means y equals 0 is a horizontal asymptote. So basically what this is telling us is that if you were to graph the function to understand what the situation is visually, as x grows, the graph of the function gets closer and closer to y equals 0. So that is our horizontal asymptote. On the other side, if you calculate the limit, x goes to minus infinity, the same thing will happen. You're going to make the same division. You're going to get the same thing here. Now sometimes things could change, because sometimes you may get different signs at the top and at the bottom, and that can alter whether this is a plus or a minus sign, or the result of this. Let's say you could get a minus 2 here and a positive 2 here, or vice versa, or you could get a plus infinity here and a minus infinity here. That could change. But in this case, because the answer is 0, even if you follow the process step by step, you're going to notice that the exact same result will happen. So that is the only horizontal asymptote for this function.